actually, sorry, my bad. Many students actually start thinking about, okay, why not to maybe approach in a bit different way. Okay, so one more time. The way to, if you start thinking in that way, let's assume that you decided to first take into account the first part of the motion. When particle P is probably somewhere here, it has some VP velocity, and from this moment you start thinking about how to calculate that basically you start consider situation from this moment of time when particle P traveled 1 second, so 1 second after, and it's your like starting positions. No problem, you can start considering situation from here. So that's why you'll get the following picture. You get a point Q, you have the point P, so you have like sort of initial velocity. So that's going to be initial velocity for first consideration, mark probably as star UP, as star, because it's not going to be 35, right? You need to calculate this velocity. And for point Q, still gonna be this value, which is 50. Okay, that's your starting point in your consideration. And after that, you understand that the time until both particles meet at some point is going to be somewhere here. So let it be midpoint. Okay, midpoint. And you probably particle P goes upward and then goes down to this point. Okay, and particle Q just goes straightly up and they meet here. Okay, that's the case what you have. Like many students start thinking from this moment, and I want to tell you that this approach is a bit harder because it takes more calculations and takes more evaluations. All right, anyway, I'll show you because other students are confused about why we start considering from very initial point of view, okay, from the very initial moment when particle P is launched. Let's consider 1 second after. It doesn't matter. It's not a big deal, except for maybe a bit more complexity. All right, so first of all, let's calculate VP after 1 second, okay, from 1 second, 1 second after. And according to the formula, it's going to be your initial P, right, minus GT, okay? So where T is 1 second, so that's why we just plug values. It's going to be 35 minus G, 10 times 1 sec. So if you calculate, you'll get 25, and that's going to be initial velocity. All right, so next point. For the next point, we can state that from using this velocity, we can probably again apply the both formulas for their position. So for point P and point Q. Now, travel time is going to be the same because 1 second has been passed, and now at this time, the second particle has been launched, okay? So that's why travel time is going to be T, and we apply the same formula for x coordinates. However, hold on, because here is going to be displacement from this point up to the median point. And you understand that initial coordinates for P, for particle P, is going to be some point x0 that we need also to calculate, because displacement is going to be final minus initial, okay, for point P. And according to consideration is going to be again Vp, right, this velocity times time, and minus gt squared over 2. As you notice, because velocity in our case 25 meter per second and it's positive, right? So we apply the positive sign. We project, it means at this point of time or at this time instance is still upward. So that's why if we input, of course, we forgot to input x-axis as in previous case, it's going to be upward. So as you understand, because the projection is positive, it still goes upward, okay? Because otherwise, maybe if at 2 seconds after, or maybe let's say 1.5, probably it might change direction, so be careful about this moment. Okay, that's why this approach is a bit harder if you take into consideration. All right, so let's move next, and for point Q, we still have initial position here at 0, so that's why minus initial position will get the same x coordinates, and original velocity for Q, t, and still minus gt squared over 2. All right, now we need to calculate x0. So coding x0, we just need to plug into the formula 1 seconds, okay? And we calculate using the same structure, but instead of VP, we're going to use UP. All right, so let's do it. So UP was 35, so we got 35 here, times time, 1 second, and minus 5, it's going to be 30. All right, as you can see, we've got 30 here, and that's initial coordinates. Okay, so let's move next. So it's going to be 30, and we just plug into the formula, and we equate both x's. So what we have the following: 30 plus 25t, and minus g over 2 is going to be minus 5t squared. That's the left side when x expressed through it, okay? So next part, x here is going to be uq, so it's going to be 50t, and minus again 5t squared. So here you can cancel more easily, and we've got the same 30 and 50 and 25, so we got 30 equals 25t, from where t is again 1.2 seconds, but don't forget to add those time, 1 second as total time. To have total time, you need to add this, obviously, and we got the same answer. So maybe more complicated in terms of taking into consideration several formulas, but this approach also works. So I'll recommend to use approach 1, which is here. It's easier in terms of start thinking from very initial conditions, and what you need to calculate is just the coordinates, okay, where they meet, while here you need to go and through several addition calculations. Obviously, to calculate displacement, you're gonna use the same way as are used here. All right, so that was challenging problem. Hope you got it, how to first transform as UVAT formula, right, in order to get the coordinates but not the displacement, okay? And the second step, to how to approach in general to this class of problem where two particles meet each other. So that was complete explanation. Hope you like that, and we're gonna move to the next problem soon. Don't forget to subscribe if you're new here, and share with anyone who's still struggling with ALevel mechanics year 1.